Good morning, everyone. This is Dr. Chris Myers coming at you with the Nutrition Lecture Series, part number 3. Within this lecture, we're going to continue our discussion on fuel sources for energy, part 2. Uh, and so for the outline of this particular lecture, we're going to review what we've discussed in the past. We're going to talk about different fuel sources. And our fuel sources include 2 of the macronutrients, carbs and fats. And also remember, we talked about the third macronutrient, protein, which is not a fuel source. We're going to discuss the 2 anaerobic energy pathways, how carbohydrates is the primary fuel source for the anaerobic pathway of glycolysis. And then we're going to move into the primary focus of this lecture of oxidative phosphorylation and what this means and how it's utilized to produce energy within the body. And we're going to discuss the fuel source associated with oxidative phosphorylation, carbs and fats, and how exercise intensity determines which fuel source, fats or carbohydrates, is the primary fuel source to create energy within the oxidative phosphorylation pathway. And honestly, don't worry, we're not going to get into all the biochemistry associated with this. We're just going to give you a macro overview to understand how the primary fuel sources affect the aerobic pathway and how we're going to leverage this to improve human performance within our training program. So in the previous 2 lectures, we showed this schematic on how on exercise intensity and duration and how it affects energy production between the 2 metabolic pathways. And we've talked in the past where kind of this magic number of 2 minutes is where you determine if you're going anaerobic or aerobic. And so if you think about it, the more intense the exercise duration, the more intense the exercise intensity is, the shorter the duration is. But the lower the exercise intensity, the longer the duration is. So keep that in mind in the back of your head as we're discussing the fuel sources in this lecture. Also, we introduce carbs and fats as the fuel sources that the body utilizes. And carbohydrates, also CHO, through several different processes, is broken down into this molecule called glucose. Glucose is a simple sugar. We introduced that in the previous lecture as a monosaccharide. But glucose is what we find in the blood. It's called blood sugar. If you have anyone with diabetes or anything like that, they're always checking their blood sugar. They're checking their glucose levels. Also, when we hear someone say, "Oh, I'm feeling tired, my blood sugar is low," this is what they're talking about. Glucose is carbohydrates are broken down into glucose so they can enter into the cell to enter into the glycolytic pathway to create ATP. And so if you remember, we talked about the glycolytic pathway is the quick energy production pathway to produce energy for the body, also known as ATP. And if we go back to our photo here, we said that the glycolytic pathway produces ATP starting here at the roughly about the 10-second mark all the way up to about 2 minutes. And so from this time point, this is called the glycolytic pathway, and it's using only carbohydrates as its energy fuel source to create ATP. Now, after that, we've got what's called the phosphagen pathway or the phosphocreatine pathway. And this is that reversible pathway where it doesn't have a fuel source. Basically, the body's just taking adenosine diphosphate to create adenosine triphosphate or ATP. It's reversible. And again, this is for the very intense energy. So if you're looking at exercise intensity roughly at about 90% to 100%, that lasts anywhere up to 5 to 10 seconds, that is your phosphagen pathway. And this pathway does not utilize carbohydrates. So if you think about it, if you're doing a 50-meter sprint, you're using only the phosphagen pathway. If you're doing a 200-meter or maybe even a 400-meter run, you're in the glycolytic pathway. But if you think about those 2 different events, They're different, they're very high intense, but they're at different intensities and different durations. And so the final thing I want to bring up is we've discussed how the macronutrient of protein, how it's utilized by the body to rebuild muscle, anything that's broken down. You need it for injury recovery, X, Y, and Z, but it is not a fuel source. It is not a primary fuel source. If the body is utilizing protein as a fuel source, that's bad. That means the body is breaking itself down. It's breaking down the muscle to create energy in order to survive. You're in a catabolic state. You're not rebuilding. Just remember that. So let's move into this concept of oxidative phosphorylation. What is it? Really, oxidative phosphorylation is the metabolic pathway that utilizes oxygen to create energy within the body. It's also known as aerobic respiration. So when we talk about aerobic endurance, we're talking about this metabolic pathway where you have to utilize oxygen to create energy within the body. And so when we put this back into our figure of intensity versus duration, we're talking about the energy pathway and beyond 2 minutes. So if you look at your exercise intensity, it can range anywhere between anywhere from 10% all the way up to 60 to 70%, depending on on how well trained you are and beyond. So for example, if you're doing it, let's use an extreme example, an Ironman event. An Ironman event can take anywhere between 8 and 16 hours, depending on how well trained you are. That is not if you look at the intensity of it, it's not very high. You're looking anywhere between 50 to 70% of one's VO2 max. And that means that intensity is not very high, so the duration is very long. And so the body is utilizing the aerobic metabolic pathway or oxidative phosphorylation to create its energy, also known as ATP. Now, within that, we utilize the fuel sources of fats and carbohydrates as our fuel sources to create energy via the oxidative phosphorylation pathway. Now, the funny part is it's dependent on the intensity of the exercise. So you can even look at exercise intensity within a spectrum within the aerobic pathway. And let's talk about that a little bit. So let's back up here a little bit. So let's walk through a little bit of an example here. You're at home, you're sitting down watching TV, not doing anything. You're not moving, you have a low heart rate, you're breathing nice and easy, you're relaxed, you're not stressed. Well, at rest, the body produces a little bit over 98% of its energy through the oxidative phosphorylation pathway at rest. You still have a little bit of the anaerobic processes, but almost all of your energy is coming from that. And so let's go ahead and now start putting it into a spectrum. And so what we have here at the very bottom is rest. And now at the very top of our spectrum, we have what's called our VO2 max. The VO2 max is our maximum oxygen utilization. So this is at very high intensities where the body is at its ceiling of utilized oxygen. And then we have this other concept of called lactate threshold. This is that imaginary band in between the aerobic pathway and the anaerobic pathways. And so what we can do is we can overlay exercise intensities on top of this. You've probably seen in a lot of the workouts where I'll put in for the runs or the rowing, do let's say 40 minutes at your heart rate zone 2. This is kind of what we're talking about. We're putting a number to the exercise intensity of where I want you to work at. And so when we look at everything at lactate threshold and below, it is completely aerobic. Now, anything above that is what we would call anaerobic. And so what we say is when it's aerobic, we're utilizing the oxidative phosphorylation pathway. The body is utilizing oxygen to create ATP or its energy. When we say it's anaerobic, we are not utilizing oxygen. And so within this, the anaerobic pathways, we are utilizing the glycolytic and the phosphagen pathway. Now, if you look at the position of where I put the glycolytic and the phosphagen pathways, is because, again, it's a spectrum. And so when we're at threshold, just above threshold, you still have the body utilizing a little bit of the oxidative phosphorylation pathway to produce ATP. This lends itself to our previous photo here of exercise intensity versus duration, where the body is primarily producing ATP or its energy at anaerobic versus anaerobic. That's our lactate threshold. And that's what we're trying to show right here. And so as that intensity gets higher and higher, the body becomes more and more predominant producing ATP versus the anaerobic pathways versus the aerobic. And then once you're at above your VO2 max, and this is pretty much you're sprinting, you're working as hard as you can. So that duration is very short with intensity very high. You're not utilizing any oxygen at all. You're purely anaerobic. You're at the phosphagen pathway with a little bit of the glycolytic. So with that being said, just remember, this is all a spectrum. And so when we look at the aerobic pathway, we're talking about everything at lactate threshold and below, all the way down to rest, or vice versa. When we're at rest, at 100% rest, again, you're sitting on the couch watching TV, low heart rate, low breathing, you are primarily using fats as your fuel source to produce ATP. If we want to get down into what the science tells us, 70% of the fuel source to produce ATP at rest is fats, with 30% being carbohydrates. Now, as you get up and start walking around, warming up, you're starting to get into a jog, that intensity is increasing. And so you're moving more from active recovery and rest up to your, kind of your regular endurance. At this point, you're starting to use a little more carbohydrates than fats. When you're a little more in zone 2, it might be close to 50-50, a little bit less, depends on your training state and stuff. But as you get higher and higher to your lactate threshold, you're becoming more dependent on carbohydrates to produce your energy as a fuel source versus fats. And so when you're at your lactate threshold, 100% of your energy is coming from the fuel of carbohydrates via the aerobic process. And this is why we can say at above that, during the anaerobic side of things, like what we talked about with the glycolytic pathway, is your fuel source is 100% carbohydrates, because once you hit 100%, you can't go anymore. So everything above lactate threshold, because it's anaerobic, is 100% coming from carbohydrates. Whereas within the aerobic pathway, it's a spectrum. So the lower the intensity, the longer the duration, fats are more and more providing more and more of that fuel source for the energy. And this is kind of the play on, this is where the thought process comes for the ketogenic diets, the carnivore diets, a lot of these diets that utilize primarily fats within what you're told to eat as your fuel source and such. And so it's just a play on that. And so I hope this helps put it into a little bit of a perspective for you. So today, we have briefly discussed the fuel source for energy production. We introduced the idea of oxidative phosphorylation, also known as of aerobic respiration. And again, aerobic respiration utilizes oxygen to create the energy for the body, whereas anaerobic respiration or the anaerobic metabolic processes do not utilize oxygen to produce the energy within the body. The aerobic pathway utilizes two fuel sources, that is carbs and fats, and it's the primary energy production for at rest and endurance events. And finally, remember the oxidative phosphorylation pathway differentiates fats and carbs as the fuel source based on the exercise intensity and duration. Thank you very much for your time. I know this is a lot to digest. In the next video in lecture 4, we're going to expand on the idea of VO2 max and training zones and how we start playing on these fuel sources within our training program. If you have any questions, reach out to me. I'm always here to answer them. Thank you very much for your time.